Hi, ladies and gentlemen. So we had our formative two that you guys took on Friday that I want to go over real quick before you guys have your summative in the future, like tomorrow. So if we take a look, our formative was on roller coasters, and we're talking about just in general all roller coasters, but on this formative, we're talking specifically about Great America. We're talking about Raging Bull. So we're talking about that, and we're talking about how at different points we can have different types of energy forming. And specifically at the top of this roller coaster, we're going to have potential energy. And as you move, you're going to gain kinetic energy. So if we take a look, we're going to solve for our givens. All right, we're going to find those up at the top. And so we find that the mass was equal to 988 kilograms, and that was given to us in our prompt. The other thing that we're going to find up there is our h, or height, is 57 meters. All right, both these are already units we care about, so we don't have to change anything. The only thing that's not given to us that we need in our equation is that G value. And that G value is our same value that we've used all semester now. And so that G value is going to be that 9.81 meters per second squared. Okay, it's the acceleration due to gravity. It does not change unless you change planets. So we have those things, and then we have our unknown, and our unknown is just our potential energy, our U. So if we know those things, we can plug those into our equation, which you guys did a pretty great job of doing. So 988 times 57 times, times the G, which is 9.81, then times 57 for the height. And then if we multiply all three of those things together, we end up with 552,459.96 joules. So quite a bit of joules, or quite a bit of energy that we have the potential to use because of how high we are up. And so now we go ahead and take a look at the second part of our problem. We wanted to figure out what that kinetic energy is when we roll down the roller coaster. So when we start moving moving a little bit more at least. So we're taking a look at this one. We have our mass, which is still the 988 kilograms. It doesn't change because you move positions, because you're still on the roller coaster. The velocity we have as 18.4 meters per second. And we know that because this is the equation for kinetic energy, and that's the only thing missing, we're solving for that K, that kinetic energy. So if we solve for that one, we plug in our K equals 1/2, or 0.5, if you will, times 988 times 18.4, and that 18.4 is squared. So I like to, again, break it up into two chunks. I'm going to do my 1/2 times my 988, and I'm going to get 494. So I'm taking half, or dividing it by 2, or multiplying it by 0.5, however you want to look at it. And then I'm going to do my 18.4 times 18.4, or my 18.4 squared. And if I do that, I end up with 338.56. Now I'm going to do my one last multiplication calculation by multiplying those two things together, and I can get 167,248.64 joules of energy. So now that we have our potential at the top, we have our kinetic when we roll down our roller coaster, we can go ahead and analyze those, or look at those two numbers and kind of find out the difference between those. So it says solve for the difference or subtract between the kinetic and potential energies. So I saw you guys doing this a lot of ways. I did not care if you did potential minus kinetic or kinetic minus potential. You get the same thing, just as a form of positive or negative. So I'm going to do my larger number of 552,459.96 minus my 167,248.64. And when I subtract those two, I'm going to end up with 385,211.32 joules. Now, this is the energy lost, or that's no longer in our potential or our kinetic. So it's no longer in either of those two. So it says what would cause the difference in these energy values? What causes this number? So this number, or this amount of energy, was lost due to the thermal energy which happened because of friction. So we lost that energy due to like the friction, which means it dissipated into the tracks. It went somewhere rather than continuing to stay in the cart. It went somewhere where the cart is not. So the tracks, it went through the wheels. Somehow heat was lost. And that heat lost was our thermal energy, which was our energy due to friction. So that's all we were looking for on this formative. If you have questions, just let me know tomorrow, guys.